All right, this is the second problem that I want to take a look at. And boy, look at this thing. So let's talk about how I think about this problem as an IB physics teacher coming up with an answer. So I have a block that starts here. Now what's clear to me is this. It's going to roll off. It's going to slide here. And then what it's going to do is it's going to arc towards the ground and then probably land like here. One thing I want to point out, this shape is a parabola. Okay. And I want to be clear here. They probably want to know the speed here as it exits. This is just my guess. Even if they don't, I'm curious as to what it is. Now, the other thing here is I'd love to use 1/2 AT squared or kinematics. I'll tell you, when they give me a height here and they give me a block, what this tells me is I'm probably going to need conservation of energy for this part here. So for this part right here, I really want to use conservation of energy. And here I would actually write E at A equals E at B. Now the problem is, this way of stating it, conservation of energy, is not in the data booklet. Let's write down formulas that are given in the data booklet. So, let's see. Am I at rest up here? Let's find out. So I notice I am at rest at A. So I can actually write that I have gravitational potential energy equal to m times g times h1. I'm adapting the formula. So this is kind of in the data booklet. So this is my energy at A. And you know what? It's actually h1 plus h2. Let's get that total height in there. And then what's my energy at B? Well, I've got some kinetic energy because I'm moving. So that's given in the data booklet. And I also have some potential energy, mg h2. I'm still high up like that. So these two are both given in the data booklet. All right. Now the other problem here, though, is this thing falls. I want to be clear here. It's going to fall and hit the ground. Now you see this horizontal V? That has no effect on the falling. So I'm going to make a note here. Does not affect the fall. I'm not writing that for me. I'm writing that for you. Now I want to be clear here. In all these problems, they always seem to want the time to fall from B to the ground. So there's a formula. Now here's the data booklet formula. The data formula booklet looks like this. S equals 1/2 AT squared plus U times T. I'm going to modify that formula for this problem. For S, I'm going to put H2. My acceleration is due to gravity. And this initial falling speed is 0. And I'm going to write a little subscript here, which I'm going to write as T fall. Now my concern here, I see this traveling distance here. This U that I'm talking about, I'm going to tell you right now, this horizontal distance that I'm going to call X is most likely equal to V times T to the fall, T times T subscript fall. In other words, I travel horizontally. The speed I'm going at is this V that I got from the energy conservation. And the time it takes to travel this horizontal distance is the same time I spend falling. I'm writing that down. I don't know if I need it. I'm writing it down because it's popped up in a ton of problems that I've done in the past. So it would appear that I've already done part A. It's the parabola. And I'm going to say C above. Now it says, show that the body will hit the floor at a distance D from a point O given by D equals 2 square root of H1, H2. Oh, so they're calling us D? Let's go ahead and change that. In fact, we change colors here. I am now in the solution to the problem. So I'm going to call this D, just like the problem does. So what am I going to do? I'm going to actually work from the beginning to the end. So let's get the speed at V. and I'm going to use energy conservation. So E at A equals E at B, and I'm going to actually use 1/2 m, EA does equal E at B, and so what that's going to be is mg h1 plus h2 equals 1/2 mv squared plus mg h2. When we actually multiply and cancel, I'm going to do some algebra here. So I'm going to say after algebra, we're going to end up getting mg h1 equals 1/2 mv squared. The m's cancel. And I'm going to actually end up getting v equals 2gh1 under a square root. All right. Now let's get the time to fall. I'm going to use that formula that I wrote down here. H2 equals 1/2 gt of falling squared. So I'm going to get 2h2 over g all under a square root is the time to fall. Finally, let's get the distance. So d equals v times t fall, and I substitute, and I'm going to get square root of 2gh1 times the square root of 2h2 over g, and we're going to get some cancellation. The g's will cancel. Square root of 2 times square root of 2 is 2, and when I solve, I'm going to actually end up getting 2 times the square root of h1 times h2. So that is my answer. I'm going to change the color here to blue so we know we're in solution. Parabola, see above. So that's it for this problem.